Have you ever been stuck with a frustrating error while coding? It can really throw a wrench in your plans, right? If you're dealing with the error while decoding OAP padding in C#, you're in the right place. Today, we're going to unravel this issue together. I totally understand how annoying it is when you think you've done everything right, only to hit a wall with an error message. You're not alone in this. Many developers face similar challenges when working with encryption and decryption. Let's dive into the specific situation at hand. One user recently reported encountering the error while decoding OAE padding when trying to decrypt data using a smart card. They confirmed that the key size is correct and that the base 64 strings match. Sound familiar? If so, let's explore this together. So, what could be causing this error? OAEP padding issues often arise from mismatched keys or incorrect padding settings. In this case, it seems to be related to the smart card being used. Let's break it down step by step. And stick around. I have a crucial tip at the end that could save you hours of debugging time. To address the OAEP padding error, the user should first verify the key size used in the encryption process. Ensure that the key size is appropriate for the RSA algorithm, typically at least 2048 bits. Next, the user should confirm that the encryption and decryption processes are using the same padding scheme. Since the error occurs with OAEP padding, ensure that both the encryption and decryption methods are set to use OAEP. The user should also check the base 64 encoding and decoding processes. Ensure that the encrypted data is correctly encoded before being passed to the decryption function. If the issue persists, the user may want to test the decryption with a different certificate. Since the user noted that decryption succeeded with a local certificate, this could indicate a problem with the smart card certificate. Lastly, the user should consider checking for any specific limitations or configurations related to the smart card being used. Consult the smart card documentation for any known issues with OAEP padding. Fun fact, the RSA algorithm is named after its inventors Rivest, Shamir, and Adleman. It's been a cornerstone of secure communications for decades. Now let's look at the answers provided by other users. An alternative solution suggests ensuring that your key size is appropriate. The RSA crypto service provider supports key sizes ranging from 384 bits to 16384 bits, depending on the cryptographic provider installed. If your key is too small, you may need to pad it to meet the minimum length requirements. Let's move forward and look at another answer. An alternative solution was shared by another user who encountered issues with certain certificates. They found that some certificates worked while others did not. To resolve this, they created a new self-signed certificate using Windows Manage File Encryption certificates. And this approach successfully resolved the decryption issue. Now, let's dive into a different answer from another user. An alternative solution from another user highlights the importance of the padding algorithm when working with smart cards. They found that using PCS1 padding works without issues, while OAEP with SHA-1 leads to decoding errors. They suggest that their smart card may not fully support OAEP SHA-1, but PKCS1 padding is reliable. Here's the tip I promised. Always test your encryption and decryption processes with both local and smart card certificates. This can help you identify hardware-specific issues early on. And there you have it. With these steps, you should be able to tackle the error while decoding OAEP padding issue. Remember, testing with different certificates can save you a lot of headaches. If you found this video helpful, don't forget to subscribe for more coding tips and tricks.